Good morning to everyone.
Good
Good
morning, ma'am.
morning.
Morning.
Good morning,
Good
ma'am.
morning, ma'am.
Yes.
Good
Good morning
morning.
to. In the previous turn, we have completed the raster analysis. In the raster analysis, you have learned about the different types of analysis operations that can be carried out on the raster dataset. Okay. So in that one, you have learned the things like reclassification, overlay, buffer, measurements, and other things. In today's turn, we are going towards the vector data. Okay. In this one, we will learn the analysis that could be carried out with the help of vector data. Now, before proceeding to this one, all of you write down what is vector data. In your copy, write down what is vector data. Those students who still have any confusion regarding the vector data, they can read this text. On the screen, I have opened a book chapter on vector data model. So this is how we actually discriminate vector data from the raster data as it is given over here. In the raster data, when we say anything is in a raster format, it means that it will have a continuous nature, like this. Okay. So on the screen, you can see that the elevations are given over here. And this one is a continuous surface, and corresponding to every position, there will be certain value. This is how we represented raster data. Anything that is continuous in nature, that can be elevation, that can be temperature, that can be rainfall, something like that, which is continuous in nature, it is called raster data. And the analysis that we have studied has a continuous nature. It was on the raster data. That's why many times raster data is also known as field data. Why? Because it is coming in a form of a continuous field. Now, if we go to the second one, which is the vector data, because broadly we can classify any of the spatial data, any of the location-based data into two categories. It can be either represented like a field, which is given right now on the screen, or it can be represented in a discrete form. Like suppose on this one is the California state, complete California state. On this one, if I want to show some of these stations where the elevation has been captured where ozone concentration has been measured. Whether it is possible to show that thing in a continuous way, the answer is we can show it in a continuous manner, but more appropriate representation of such type of discrete gauge means measuring stations will be in a discrete manner in a vector form. So that's why if I check on these places, so if I check on these places, they are coming in a discrete green color form. So this is what? This is the vector data. Anything that is represented discretely, like if it is a point, it will be represented in the form of XY coordinate. How line will be represented? Write down the definition of line in your copy. These are the basic things that you must know. What is the definition of line? So line is an ordered pair of a set of coordinates which are joined by, where every coordinate is joined by the next consecutive coordinate by a straight line. This is how we define a line. Similarly, we define a polygon. That polygon is an ordered set of coordinates where first and the last point are same. This is how in a vector data the point, line and polygons are represented. Now let's start with the type of analysis that could be carried out on this data. First one is about the measurement. Okay, how a distance is measured on the raster data. Anyone? How do we measure a distance on a raster data?
Um, uh, three three types: first Euclidean, and then Manhattan, and proximity.
Yes. So there were three different manners in which a distance between 2 points could be computed. First one is the Euclidean distance, which is a by using the Pythagorean theorem, we get the distance between the these were the three different ways through which a distance between 2 points could be measured. Between A and B, it could be measured by using a Euclidean distance, which is a Pythagorean distance. Second one is a Manhattan distance. How Manhattan distance is computed? If you move along the side, like this is a straight line for the Euclidean, A1, B1, there is a straight line. But what Manhattan distance says that many times it is not possible to go through a cell. So instead of moving through this cell, how the navigation is taking place along the edges of the cells which are intersected by this straight line. So see the Manhattan distance, see the distance between A2 and B2. Third one is the proximity, or which is showing the spread from A3 to B3. This is how we have learned the computation of length in case of raster data. But when we come to the vector data, this
Ma'am,
computation, yes.
ma'am, if we are asked to define this proximity distance, then how we can define in words, ma'am?
As it is given over here, proximity in this method, concentric equidistant zones are established around the start point A, or in this case it is A3. So we are going to create equidistant points. One by one you will move at the equal distance, 2, 2, and then there is a 2.8. So the resulting image shows the shortest straight line distance from every point on the map to the location of interest. So this is how you will define the proximity distance in terms of what? That you are going to create equidistance zones from the start point as you move towards the end point or the destination point. So coming to the vector part, there are three different ways that we have seen for the raster data, but in case of vector data, there is only one distance, which is the distance between 2 points, that is Euclidean distance. So everyone know about this formula which is given on the screen. It is regularly used when we have to compute a distance in a coordinate geometry. It is x1 minus x2 square plus y1 minus y2 square and under root of that value. So there is only one distance which is computed in case of vector data. It is the Euclidean distance between 2 points. Then centroid. So it is the center of gravity. In this case, all the coordinates are summed and divided by the number of vertices. Okay. Next one is perimeter and area. In case of raster data, the computation of perimeter and area was very simple because in raster data, the things are based on cell. You just need to count the number of cell and multiply by the area covered by a single cell. So you will get the area. For the perimeter again, there is just a requirement to compute the number of cell sites that are occurring on that figure. But in case of vector data, it is a little bit complicated over here because in this one, we first need to convert that area, that shape into a regular geometry, and then by using the standard formulas, the area or anything else will get computed. So things are not that much simple in case of vector data, but the area is calculated by first converting the given figure into a regular geometry. And then as you can see in this particular example that this colored figure is given over here and the area of DEF is computed by using this formula 1 plus 2 plus 3 minus 4. Okay, so this is how the area is calculated in case of vector data. Now coming to the next part, which is about the buffer. In the raster also we have learned about the buffer. This buffering operation could be applied on both on the raster data as well as on the vector data. So when you have any question related to the proximity, okay, related to the nearness or area of interest around any of the feature or any of the entity, in that case, there is a chance that you will have to perform the buffer operation. This thing is important because the question can be placed in two ways in the examination. First one is a simple straightforward manner that what is buffer, okay? In that case, there is no problem. You just need to mug up all these things and write it down on the answer sheet. Otherwise, and in general, there will not be any straight what, why, where, not this type of question. The questions many times come in the examination in the analytical form. Okay. Like the question might be given like, you know, there are some points representing the hospitals and you need to identify the zones within the 1 kilometer from the hospital that is free from noise, something like that. So which operations will you perform in this case? So one of the operation that is required, there will be several types of operation that will be performed in order to solve this spatial problem. But one of them is buffer. Why? Because it is clearly mentioned that you need to identify the noise-free zone around 1 kilometer from the hospital. So this is important because many times, or you can say most of the time in the examination, the question is going to come in this way. Okay, there will be some question in which you have to analyze, in which you have to think, and only then you could solve the problem. Now, if we see the buffer, as you remember previously, buffer is about creating a zone of interest around any of the entity. That entity could be a point, it could be a line, it could be a polygon or area. Okay. If we see one by one point, okay, if you try to create a buffer around a point, what will be the shape? as it is given on the screen, it will come in a circular form and the radius will be equal to the buffer distance which is mentioned. Like the example which I have given, hospital, and around the hospital 1 kilometer zone. So the radius of the buffer will be 1 kilometer. Next, line. Okay, this is how the buffer around a line is created. So there will be a circle, okay, and the radius of that circle will be equal to the buffer distance. That circle will move along the line and then a tangent will be created around that path like this way. So this is how the buffer zone around a line will be created. Similarly, the buffer zone around a polygon will get created. Okay. So I will show you this thing on the software. Like right now on the screen, you can see the Brooklyn subway stations. Okay, so there are several points that are representing the Brooklyn stations. Now you want to identify half kilometer area that is coming around the Brooklyn. So what I can do, geoprocessing, and I have this buffer operation over here. So if I click on the buffer, and I want to create a buffer of 500. So this is how a buffer around a line will get created. Similarly, I will show you one more. Yeah, there are some school sites also. If I want to create a buffer of 500 meter around the schools, so this is how a buffer will get created around these schools. If you check the attribute table, okay, like suppose if I open the attribute table of Brooklyn buffers, they have the same attribute table as it was for Brooklyn subway station. So whatever entity is used, the buffer will also carry the same set of attribute, plus there are few additional attributes that are added over here. Okay, so buffer distance of 500 meter, shape length which is equal to 2 pi r, and shape area pi r square. This is the standard formulas that can be used over here, and this is how the buffers would get created over here. So this is about the buffers that will be created around a line, around a point. Similarly, you can see how the buffers are created. Straight. There are some roads over here. Okay. Now suppose if I want to create a buffer around these roads, see how it is coming over here. There's some roads. Buffer road. Okay, now suppose there is a question. If the width of a road is, say, suppose 200 meter. Okay. So listen this question. Suppose the width of the road is 200 meter. what will be the buffer distance? If I want to mark a road, the roads are shown by a line without any width. Now in the question it states that the road has a width of 200 meter. What will be the buffer size? What value will I put place over here?
I'm 100.
Okay, anyone with 200?
No, no, ma'am. 100.
The answer is 100. Why? Because in the question it is stated that the width of a road is 200 meter. So if you create a buffer of 200 meter, the buffer will be created on both the side. So 200 on one side, 200 on another side, it will create a total buffer of 400 meters. So the width become 400 meter, not 200 meter. So if I take 100 meter and click OK, see what will happen. Okay. Like this. So in this one, 100 on each side of the road, 100 is created on both the side, 100 on one side, 100 on another side. So a total width will be 200 meter. So this is how a buffer around a road is created. Similarly, if you have a polygon, the polygon will also form, the buffer is also formed around that polygon. These operations are very useful. Like suppose in the very school example, if I take the school example like this, okay, check this one. Now there are 5 schools in this locality and a buffer is created over here. Now suppose a government says that there should be no liquor shop within 100-meter zone or 200-meter zone of these schools. How we can do this thing? So one of the proposed solution could be that first of all we can create a buffer like this way, and later on we can import this buffer data on the Google Earth. Like I will show you this thing. So in this one on the screen, you can see that there is Google Earth, and I have already imported the buffers which are created around the school. And these buffers are at 100 meter. Okay, in the left hand side panel, see, I have placed my cursor over here. Buffer school 100 meter. So these schools are created at a buffer of 100 meter. Now if I zoom in, as you can see over here, okay, if it is not appearing, just wait. Instead of white, I am taking red color. Yes. Now on the screen, you can see these red color circles over here. Okay. So these are the same circles that we have created in the ArcGIS over here. Okay. So first what I have done, I have taken the schools. I have a shapefile of the school. Then I have created a buffer of schools. Then I have imported that data on the Google Earth. And now if I zoom in, like on one of, you can see the attribute table of the school. So this is the Stowe Junior Senior High School. So now you can clearly see on the Google Earth that there is one school which is located over here. It is already labeled by the Google Earth also, Stowe High School, and see how a circle is created around it. So you can identify that what is the 100-meter zone around this school, what things are coming around this school. Like you can see that there is some sports ground is coming over here. Then there is one road which is over here. All this information is available. So this is how we can integrate this data in this manner, and we can later on see all the information like this way. All the schools are coming. There were 3 schools. Just wait. Again, you can see it over here. There were 3 schools that are present at this location. Again, you can see the information of these schools over here also. Okay, so there is one school which is located over here. You can see that there are several streets that are going around this one. Some main roads are coming around this way. So we can say that, this school is located around some of the main roads. So a special traffic police should be deployed at this location during the start and closing time of the school. Similarly, there is another school. The surrounding is available over here. So this school is not directly connected with the main roads. There is only one road which is coming to this school. So this is how you can propose a solution. You can identify the region and propose the solution over here. Okay. Another thing that we have created the NYC data also, the buffer of that one. Okay. What I will do, see how means Google Earth is not a part of our syllabus or curriculum, but still you can see this thing is open source. So anyone of you can download and install the Google Earth software in your own system, and you can also see your data set. Okay, like the data set that you have digitized, you can also that one over here. So like this is the school data which I have already imported. Now I'm going to import the the road data. See, it will take some time. See, all the roads. Just wait, I will do one thing. See, all the roads have been marked, and you can see on this one, you can see the zone which is coming within the 100-meter range of these roads. Like suppose there is some proposal that, along the highways, along the roads, there is a development plan and new motels, washrooms, petrol pumps will be developed around the 100-meter range of any national highway or state highway. So this is how we can propose our own solution. We can first demarcate that region which is falling within the 100-meter region from the road. On both sides of the road, you can see these white lines. These white lines are showing the limit of 100 meter. Okay, and this is how you can identify the whole region. Okay? Like, this field, like government, the people can say that our agriculture field is coming. See, within this 100-meter range, this agriculture land is coming. Okay? So this is how you can use a buffer. So this is about the point buffer, line buffer, and a polygon buffer. They are very useful, and remember one thing, whenever there is a question which is related to the proximity, which is saying nearby within this range, remember that you need to perform buffer analysis over there. Second thing is about what will be the size of buffer. Also always think, directly we have a nature that 200 meter around this entity. So we directly start creating 200-meter buffer around the point, line or polygon, whatever entity is given over there. So read the question carefully. Like the example I have given you about the road, the width of the road is 200 meter. So in that case, you have to create a buffer of 100 meter on both the sides. Buffer distance will in that case 100 meter, not 200 meter. Now coming to the software parts, there are several options that are available when you perform the buffering. Okay, there is one dissolve option. What is the meaning of dissolve? There is a dissolve function. What is the meaning of dissolve?
घुल जाना मैम.
घुल जाना. तो यहाँ पर क्या घुलेगा? बफर के टर्म्स में क्या होगा?
मीन्स सब कुछ एक साथ मिक्सअप हो जाना, मर्ज कर जाएगा या तो
नहीं,
ओवरलैप
सब
हो
नहीं,
जाना
नहीं, सब नहीं। चल, इसको एग्जाम्पल से देखते हैं, फिर अपने आप समझ में आएगा। ये स्कूल्स देख रहे हैं, इनका बफर देख रहे हैं कैसे बन रहा है। जब ये वाले बफर क्रिएट किए गए थे तब बफर ऑप्शन सेलेक्टेड नहीं था, मतलब अनेबल्ड, डिसेबल्ड था। अब देखिए हम यही वाला प्रोसेसिंग फिर से परफॉर्म करते हैं। 500 मीटर का था। डिसॉल्व नन है, यहाँ पर डिसॉल्व नन की जगह ऑल कर दिया। अब देखिए क्या होता है। अंतर समझ में आया? डिसॉल्व ऑपरेशन जब होता है, अब यहाँ पर जैसे ये वाले स्कूल्स हैं तो यहाँ पर कोई दिक्कत नहीं आई, इनके तो स्कूल्स अपने क्योंकि सेपरेट इनके बफर बन रहे हैं, दूर दूर बन रहे हैं, नो प्रॉब्लम, यहाँ कोई डिसॉल्व वाला कॉन्सेप्ट आएगा ही नहीं। लेकिन जो ऊपर 3 स्कूल थे वो बहुत पास पास में बने हुए थे, तो उनका जब हम लोग 500 मीटर का बफर बनाते हैं तो उनका जो बफर की बाउंड्री है वो आपस में ओवरलैप करने लग जाती है। ओवरलैपिंग को रिमूव कराने के लिए हम डिसॉल्व को इनेबल करते हैं। ठीक है, डिसॉल्व का जैसे सपोज अगर क्वेश्चन में पूछा जाए या अगर कभी आप लोग को परफॉर्म करना हो कि अगर आपके पास में इंडिया का बाउंड्री मैप है, ठीक है, डिस्ट्रिक्ट लेवल बाउंड्री मैप है, आपसे बोला जाए स्टेट मैप में इसको कन्वर्ट करिए। समझ में आ रहा है क्वेश्चन? इंडिया का आपके पास में एक शेप फाइल है और वो शेप फाइल जो है वो डिस्ट्रिक्ट लेवल का डिजिटाइजेशन दिखाती है। आपको कहीं रिक्वायरमेंट ऐसा है कि आप डिस्ट्रिक्ट लेवल की शेप फाइल नहीं दिखाना चाहते, आप स्टेट लेवल की शेप फाइल दिखाना चाहते हैं, वहां पर कौन सा ऑपरेशन लगेगा?
डिसॉल्व।
यस, वहां पर डिसॉल्व ऑपरेशन लगेगा। मर्ज अलग होता है, डिसॉल्व अलग होता है। तो ये ध्यान रखिएगा कि जब बाउंड्रीज जो है, जैसे एक आपको हायर लेवल ऑफ एग्रीगेशन पे जाना है, जैसे डिस्ट्रिक्ट से स्टेट पे जाना है या स्टेट से कंट्री लेवल पे जाना है, वहां बाउंड्रीज जो होती हैं वो डिसॉल्व होती हैं। ठीक है, तो वहां जो ऑपरेशंस होंगे वो डिसॉल्व ऑपरेशन परफॉर्म होगा। बफर में एक वेरिएशन और है, उसको एक मल्टी रिंग बफर आता है। यहाँ पर देखिए मल्टीपल रिंग बफर यहाँ पर ऑप्शन लिया गया है और डिस्टेंस 100, 200, 300, 400 ऐसे करके डाला गया है। आउटपुट में देखिएगा क्या होता है।
मैम हम लोग को भी ArcGIS सिखाया जाएगा?
नहीं, आप लोग को QGIS सिखाया गया है तो बिल्कुल सेम फंक्शनैलिटी QGIS पे भी होगी, मतलब वो दोनों ही इक्विवेलेंट सॉफ्टवेयर हैं आपके। समझ में आ रहा है क्या हुआ यहाँ पे? यहाँ पर देखिए स्कूल मल्टी रिंग बफर यहाँ पर बने हैं 100, 200, 300, 400। कई बार हमारा रिक्वायरमेंट होता है कि हम अलग अलग किसी भी एंटिटी के अराउंड हम लोग अलग अलग जोन्स क्रिएट करें। ठीक है, अलग अलग डिस्टेंस के जोन क्रिएट करें, उस केस में इस तरीके से मल्टी रिंग बफर यूज होता है। ठीक है। लाइक सपोज हम लोग अर्बनाइजेशन स्टडी कर रहे हैं, कितना अर्बनाइजेशन है, तो ये सिटी सेंटर है, तो सिटी सेंटर से जैसे जैसे हम दूर जाते जा रहे हैं, अर्बनाइजेशन का कितना अंतर आ रहा है, कितना डिस्पर्जन हो रहा है, कितना कॉम्पैक्ट डेवलपमेंट बना रह रहा है, उन केसेस में हमें क्या करना पड़ता है, हमको पूरे रीजन को अलग अलग जोन्स में डिवाइड करना पड़ता है। तो वहाँ एक सिंगल बफर से काम नहीं चलेगा, इस तरीके से मल्टी रिंग बफर को बनाना पड़ेगा, और तब जाकर के काम होता है। ठीक है, तो ये एक और बफर का आपने दो तीन और तरीके देखे, एक सिंपल बफर था, एक डिजॉल्व या नेस्टेड डिजॉल्व बफर था, ये मल्टी रिंग बफर कहा जाता है। तो इस तरीके से अलग अलग बफर्स के ऑप्शंस होते हैं। ये धीमे मतलब बफर का बेसिक थ्योरी तो आप लोग ने सीख लिया। बफर क्या है? बफर इज द प्रोसेस ऑफ क्रिएटिंग एन एरिया ऑफ इंटरेस्ट अराउंड एनी ऑफ द एंटिटी, ये सिंपल डेफिनेशन है बफर का। बाकी की बफर क्रिएशन में आपको बहुत से वेरिएशन मिलेंगे। कई बार बफर जैसे एक किसी फील्ड के एट्रीब्यूट के अकॉर्डिंग क्रिएट कराया जा सकता है। यहाँ तो हमने मैनुअली एक डिफरेंस अलग अलग वो दे दिया, 100 200 300, है ना। कई बार क्या होता है कि हमारे पास में अगर कोई फील्ड है, उसके अकॉर्डिंग, लाइक सपोज हमारे पास में कैटेगरी है, सपोज रोड है, रोड की कैटेगरी है, लाइक सपोज 100 इज रिप्रेजेंटिंग स्ट्रीट, 200 इज रिप्रेजेंटिंग से नेशनल स्टेट हाईवे, 300 इज रिप्रेजेंटिंग नेशनल हाईवे, इस तरीके से हमने कर दिया। तो अब हम बफर जो है, लेयर तो हमारे पास में एक ही रहेगी, रोड की लेयर, लेकिन उसके अंदर एक फील्ड अगर हमने इस तरीके से डाल दी कि जिसमें जो उसकी कैटेगरी है उसके अकॉर्डिंग उसका एट्रीब्यूट हमने असाइन करा, और फिर वहां पर हमने एट्रीब्यूट के बेसिस पर बफर बनाया। तो ऐसा भी ऑप्शन अवेलेबल है कि वेरिएबल बफर्स बनाए जाते हैं डिपेंडिंग अपॉन दी फीचर। एक एंटिटी में जो अलग अलग फीचर्स प्रेजेंट हैं, है ना, रोड एक एंटिटी हो गई, उसमें अलग अलग फीचर टाइप है, लाइक स्ट्रीट, नेशनल हाईवे, स्टेट हाईवे। इन अलग अलग फीचर्स को उनके इंपॉर्टेंस के अकॉर्डिंग अगर हमें बफर बनाना है इसके अराउंड, तो एक एट्रीब्यूट लेकर के उसके बेसिस पर भी इसको क्रिएट कराया जा सकता है। बफर का हो गया। नेक्स्ट, ओवरले। तो इसका थ्योरी ऑलरेडी हम लोग ने रास्टर में देखा हुआ है। रास्टर ओवरले सेम यहाँ पर भी हो रहा है, लेकिन इस केस में डिफरेंस आ जा रहा है। क्यों? क्योंकि यहाँ पर हम रास्टर ना लेकर के वेक्टर डेटा लेते हैं। रास्टर ओवरले का अगर आप परफॉर्म करेंगे तो प्रोसेस काफी सिंपल होता है। क्यों? क्योंकि वहां पर सेल बाय सेल बेसिस पर पूरा कैलकुलेशन होता है। इस कारण से उसको मैप अलजेब्रा, आपको याद होगा जो वेडनेसडे के टर्न पे जब हम लोग कर रहे थे, तो वो मैप अलजेब्रा के टूल के ही थ्रू वो पूरा का पूरा ऑपरेशन परफॉर्म किया जा रहा था। रास्टर में करते टाइम ओवरले इजी होता है, सेल बाय सेल बेसिस पर होता है। प्री रिक्विजिट या कंडीशन क्या होती है करने से पहले? सेल डायमेंशन सेम होना चाहिए, कोऑर्डिनेट सेम होने चाहिए, और अलाइनमेंट होना चाहिए, लेयर्स प्रॉपरली अलाइंड होनी चाहिए। अगर मिस अलाइनमेंट है थोड़ा सा भी, तो ओवरले सही से नहीं आता है, इनकरेक्ट रिजल्ट्स आते हैं उसके। अब यहाँ पर हम कहाँ जा रहे हैं? हम लोग अब वेक्टर ओवरले को पढ़ने जा रहे हैं। वेक्टर ओवरले को पढ़ने से पहले अब आपका काम क्या है? अपने अपने कॉपी पे लिखिए ओवरले से अब आप समझते क्या है। ठीक है, उसको मत देखिए। ओवरले को अगर हम बोले, क्वेश्चन इज व्हाट इज ओवरले एनालिसिस। डेटा टाइप की नहीं बात कर रहे, वेदर इट इज अ रास्टर डेटा और वेदर इट इज अ वेक्टर डेटा, डजंट मैटर। द क्वेश्चन इज जस्ट अ जेनरिक क्वेश्चन, what do you understand by overlay analysis, and in which condition you will apply the overlay analysis। ये क्वेश्चन बहुत जरूरी है, क्योंकि ओवरले एनालिसिस क्या है, इसकी थ्योरी तो ठीक है आप याद कर लीजिए, लेकिन ओवरले कब लगाना है, किन कंडीशंस में ओवरले लगाना है, ये जानकारी होना बहुत जरूरी है। क्योंकि तभी आप जो प्रॉब्लम्स होंगी, जो स्पेशल क्वेरीज आपको दी जाएंगी, उसको आप सॉल्व कर सकते हैं। तो जल्दी से लिखिए व्हाट इज ओवरले एनालिसिस। The answer is overlay analysis is used to combine the spatial and attribute data from two or more layers. जहां कहीं भी क्वेश्चन में आपको एक से ज्यादा लेयर को लेते हुए आंसर करने की जरूरत है, एक से ज्यादा स्पेशल डेटा को इन्वॉल्व किया जा रहा है, उस केस में दोनों डेटा को आप इंटीग्रेट कैसे करेंगे? ओवरले लगा करके। ओवरले केवल मतलब ज्योमेट्री में ही ओवरले नहीं होता, दोनों में होता है। जैसे कि आप इस फिगर में देख रहे हो, ओवरले बाय यूजिंग द लेयर। सो लेयर ए एंड बी दोनों एक दूसरे पे ओवरले होकर के आपको एक लेयर का ओवरले दिखा। एंड राइट हैंड साइड एट्रीब्यूट फॉर लेयर ए, एट्रीब्यूट्स फॉर लेयर बी, देन कंबाइन एट्रीब्यूट ऑफ लेयर ए एंड बी। सो ओवरले ऑपरेशन दोनों में होगा, जो उस लेयर का ज्योमेट्री है और जो उसका एट्रीब्यूट है, दोनों को मिला करके ओवरले होगा। ओवरले के डिटेल में जाने से पहले इस टर्म को देखिए, सीव मैपिंग। ठीक है, सीव मैपिंग। सीव मैपिंग क्या होती है और इसका कॉन्सेप्ट कहां से आया? सीव मैपिंग कुछ इस तरीके से होती है। आप लोग को एक बहुत पहले बुक, जब हम लोग डेवलपमेंट ऑफ जीआईएस पढ़ रहे थे, एकदम स्टार्टिंग लेक्चर्स में, इवोल्यूशन ऑफ जीआईएस, वहाँ एक बुक का नाम था डिजाइन विद नेचर, है ना? एक बुक का नाम उसमें बताया गया था, डिजाइन विद नेचर। उसके ऑथर कौन थे?
यान मैकहग।
यान मैकहाग। यान मैकहाग एक ऑथर थे, एक बहुत इन्फ्लुएंशियल पर्सनालिटी थे इन्वायरमेंट की फील्ड में। ठीक है, उन्होंने एक बुक लिखी थी और वो बुक लिखी थी इकोलॉजिकल लैंडस्केप प्लानिंग के ऊपर। उस बुक का नाम था डिजाइन विद नेचर। तो बेसिकली वो एक लैंडस्केप आर्किटेक्चर के तौर पर जो लोकेशंस थी, उनके लिए वो बुक लिखी गई थी। उस बुक ने ये कॉन्सेप्ट दिया था सीव मैपिंग का, जो आगे चल करके जीआईएस में इंक्लूड हुआ ओवरले के नाम से, है ना? इसमें किया क्या जाता है, इसमें आप देख रहे हैं यहाँ पर एक ऑपरेटर है, उसके स्टेप 1, स्टेप 2, स्टेप 3 दिया हुआ है। ये सीव मैपिंग है जो यान मैकहाग की बुक में बताया गया था, क्योंकि उस समय कंप्यूटर्स नहीं आए थे और आज के जैसा एडवांस जीआईएस नहीं यूज होता था। इसमें स्टेप 1 में जैसे दिखाया जा रहा है, सबसे पहले ऑपरेटर ने क्या किया, एक ट्रांसपेरेंट शीट ली, माइलर शीट ली, और उसके ऊपर जो उनका स्टडी एरिया था उसको पेन लेकर के पूरे एरिया को ट्रेस किया। स्टेप 2 में आप देखेंगे यही काम हो रहा है। स्टेप 2 में वो पूरा का पूरा रीजन ट्रेस हो रहा है। इसको करने के बाद अगर आप देखें स्टेप 3 में, वहां पर क्या हो रहा है, स्टेप 3 में एक और शीट लगा दी जा रही है और उसमें कुछ एक पर्टिकुलर एरिया को कलर करा जा रहा है रेड कलर से। सीव मैपिंग में इस तरीके की एक नहीं कई सारी शीट बनती थी। ठीक है, इस तरीके की कई सारी शीट बनती थी, क्योंकि जब आप बहुत सारे डेटा को, लाइक सपोज कोई साइट सिलेक्शन है, उसके लिए बहुत सारे कंडीशन आ रहे हैं कि इस पर्टिकुलर डिस्ट्रिक्ट की बाउंड्री के अंदर होना चाहिए, स्कूल से दूर होना चाहिए, घरों से दूर होना चाहिए, डंपिंग स्टेशन के पास में होना चाहिए। इस तरीके के कई सारे रूल्स अगर आप लगेंगे तो एक ही शीट पर ये सब चीज को ड्रॉ करना मुश्किल हो जाता था। तो कई सारे जितने कंडीशंस होती थी उतनी ट्रांसपेरेंसीज रखी जाती थी, और हर एक ट्रांसपेरेंसी में जो भी रीजन सेटिस्फाई नहीं करता था कंडीशन, लाइक सपोज कंडीशन है कि द साइट शुड बी एटलीस्ट 1 किलोमीटर अवे फ्रॉम द रेसिडेंशियल एरिया। तो हर वो जगह जो रेसिडेंशियल एरिया से 1 किलोमीटर के अंदर आती थी, इसको ध्यान से सुनिएगा, कंडीशन क्या है, द डंपिंग साइट शुड बी एटलीस्ट शुड बी 1 किलोमीटर अवे फ्रॉम द रेसिडेंशियल एरिया। तो यहाँ पर कौन सा एरिया सूटेबल नहीं है उसको ब्लैकआउट किया जाता था, उसको कलर किया जाता था। तो रेसिडेंशियल एरिया के 1 किलोमीटर के अंदर का एरिया पूरा सूटेबल नहीं है, तो उसको कलर कर दिया गया। देन the location should be 2 kilometer away from the schools. Okay, तो स्कूल के 2 किलोमीटर के अंदर का रीजन वो पूरा कलर कर दिया गया। it should be within 1 kilometer from the highway. So हाईवे से 1 किलोमीटर के बाहर का एरिया जितना होगा उसको कलर कर दिया गया। और फाइनली इस तरीके की जितनी भी शीट्स होती थी उनको प्रॉपरली अलाइन करते हुए एक साथ रखा जाता था और लाइट उनके थ्रू पास कराई जाती थी। जहां कहीं से लाइट विदाउट एनी ऑब्स्ट्रक्शन क्लियरली निकल करके आ जाती थी वो डिजायर्ड साइट होती थी। ऐसी साइट जो सभी कंडीशंस को सेटिस्फाई करती है। इस तरीके से सीव मैपिंग में काम होता था। इसको हम एक बार रीड आउट कर दे रहे हैं। Sieve mapping is the GIS version of an old technique used by land use planners to identify areas suitable or not suitable for some activity. To start, the entire study area is considered as suitable. So at the starting point, the entire study area is considered to be suitable. Then areas are disqualified on a series of criteria until all remains are areas still considered suitable. Before the advent of GIS, this method made use of a light table and a series of transparent map overlays, one for each criterion, on which the areas deemed unsuitable were blacked out. When a set of binary maps are stacked on top of each other, light shines only through those areas which seem to be suitable, hence left unshaded on all the overlaid maps. Although this technique was first formalized by landscape planner Ian McHugh, he was one of the key developers and promoters of overlay-based techniques for the planning. So for the map overlay, there were four different steps. First of all, determination of input means what will be the criteria. So we must decide which maps to overlay and in a Boolean sieve operation, what threshold to set to determine whether areas are suitable or unsuitable. Second, get the data. This step involves the assembling the required data and preparing the individual maps, one for each criteria to be used. Third, referencing the maps to the same reference system or co-registration. If results of any overlay are to make sense, it is vital that all inputs are georeferenced to the same coordinate system. So the same part of the Earth's surface is at the same place on every map. Next, overlaying the map to sieve out the unsuitable area, producing a map showing only areas suitable in the context. Technically, this step is different in raster and vector data structures, but the underlying principle is the same. So this is all about the traditional sieve mapping technique, which later on developed into the overlay analysis. And overlay analysis is the fundamental operation in GIS. All the time we perform overlay analysis. Like if I show you, I was showing you this diagram. On the Google Earth, I was showing you this buffer of road. This one is also overlay. Basically, I'm doing the overlay. This one is the visual overlay that is done over here because this road layer, this road buffer layer has been overlaid on the image of the earth. So this is what? This is the visual overlay. We are not performing any operation over here, but we are just visualizing the things that are coming within the 100 meter from the road. All the time we are performing the overlay. When you are opening different layers on any of the software, okay, like on this software, on the ArcGIS software, what I have done, on the base, I have opened the elevation data, and on the top of that, I have opened the measuring stations. Okay. Again, this one is the visual overlay that is created over here. But apart from the visual overlay, the actual overlay is also very powerful tool. And through that overlay, we are going to combine different data set. Okay. Now, when we talk about the vector overlay, the vector overlay will involve point, line, and polygon geometry and the association of the attribute data with that one. Okay. So overlay when using a vector data model involves the combining point, line, and polygon geometry and associated attribute data. This overlay creates new geometry. The overlay involves the merger of both the coordinate and attribute data, means both things are going to get combined from two vector layers into a new data layer. The coordinate merger may require the intersection and splitting of lines or areas and the creation of new features. See this example? See how the vector overlay is done. There is layer 1, layer 2 and the output layer. See the change in the geometry as well as in the attribute table. So layer 1 is having a geographic data. Layer 1 and 2, there are two features in this layer. Their ID and class is given over here. In layer 2 again there are two features 1 and 2. The ID and cost of that one is given over here. In the output you can see that total 4 features get created because of the overlay, and in this one the ID there are 4, 1 2 3 4, the class and the cost is given over here. When we talk about the overlay analysis over here, there are 3 types of overlay: point in polygon, line in polygon and polygon on polygon overlay analysis. Although you can perform any type of overlay, even you can perform line and point overlay, but they will give you, means the output will not make any sense. So overlay can be done between any two layers, but we have to make sure that they are making some sense over there. Okay. So in this particular example, this one is the point in polygon overlay analysis. In this one, if you can see in the example, which is given over here, the metrological stations are given. In the second polygon layer, the land use information is given, whether the area is forested or not forested. Now suppose there is a question that you need to identify whether a meteorological station falls inside a forest or not. Okay. So if you want to associate the information of land use with the meteorological station, what you will do? You will perform the overlay analysis as it is shown over here. Okay. So this is what? This is point and polygon overlay analysis, and it is used to find out the polygon in which a point falls. For example, meteorological stations are represented as points and land use as polygons. Using point and polygon overlay on these vector data layers, it is possible to find out which land use polygon each meteorological station is located. On the output map, a new set of meteorological station points is created with additional attributes describing the land use. Then the second one is line and polygon overlay. Like again, you can see in the example, suppose there is a question that you need to identify whether the road is going through the forest or not. Okay, there is some planning over there, and for that purpose they need to identify whether the road is going through the forested area or not. See the result. See what is happening over here. First layer is a line, second one is the polygon, and see what is happening when the intersection is taking place. Whenever there is an intersection, the number of features is going to increase. I hope everybody know what is the difference between entity and what is feature. So what is entity over here? There are two entities. First entity is road, second entity is forest. How many features are present inside the road entity? There are 3 features, 1, 2, 3. In the forest entity, there are 2 features, forest and non-forest. After the overlay, the output is a new entity is created, and how many features are present over here? Total 5. Okay, and you can see new ID and land use information is associated with that one. Okay, so line and polygon overlay is more complicated. Imagine that we need to know where road passes through forest areas to plan a scenic forest drive. To do this, we need to overlay the road data on a data layer containing forest polygons. The output map will contain roads split into smaller segments representing roads in forest areas and roads outside forest areas. Topographical information must be retained in the output map. Therefore, this is more complex than either of two input maps. The output map will contain a database record for each new road segment. Okay, so here you can see in the attribute table, the new ID is generated and the corresponding land and use information is also associated with that one. So this is how the line and polygon overlay analysis will take place. The next one is polygon on polygon overlay analysis. So it will be a longer topic. First, I'm giving you 10 minutes break. And after that, we will start from polygon on polygon overlay analysis theory. And later on, we will see the examples on the software also. Okay, so 10 minutes break. So let's start the class again. So till now we have seen the point in polygon and line in polygon overlay analysis. Now we are moving to the third type, polygon on polygon overlay analysis. In this case, both the layers will be polygon. And there are there are several operations that you can perform for the overlay. Means you can perform the union, you can perform the intersection, you can perform the erase, you can perform the symmetric difference. Okay, two polygon layers could be overlaid by using various functions. Now this is not for the point and polygon and line and polygon, but for the polygon on polygon there are several options. Few of them are given over here. First one is showing the union operation or simply OR operation, in which information of both the layers will get combined. Now in the output layer, how many features will be present? In the first layer there are two features. In the second again there are two features. First one, that area which is lying inside the forest, and that area which is falling outside the forest. Second one, area which is inside the resort and the area which is outside the resort. In the overlaid layer, in the union layer, how many features will be there?
4.
4. Anyone with any other number? What will be these 4 features?
Inside the forest inside the resort, forest outside the resort, and non-forest inside the resort and non-forest outside the resort.
Yes. So there will be in the output, in the first there will be 2 rows, in the second there will be 2 rows, but in the overlaid data after the union you will get 4 rows in the attribute table. So as it is clearly told to you, there will be 4 possible combination over here: forest, forested resort, non-forested resort, non-forest, non-resort, and both. Next one is by using erase. Okay, like suppose there is a question, you need to identify all those area of the resort which is not falling inside the forest. In that case, you will perform the not operation. Third one, and where both the resort and forest are falling. So these are the different methods through which you can perform the overlay. This figure is summarizing all the 3 point in polygon, line and polygon and polygon overlay. Okay. Now let's see all these things on the ArcGIS. So what will be the, like suppose there is a question that in the Brooklyn stations, if I open the attribute table of the Brooklyn stations, let's wait. Now here you can see in this particular attribute table, the detail of the subway station of the Brooklyn is given over here. But suppose if I want to know about the census block. Okay, suppose I want to associate the information of census block which is falling, in which these stations are falling. What will I do? Okay, like suppose there is a question that I want to suppose I want the Brooklyn NYC Brooklyn subway stations and the block ID with them. What operation will I perform? In that case, I will perform like, suppose I will perform intersection. So input I am taking Brooklyn stations, then I am taking Brooklyn blocks, and see I am performing okay. So the intersection is going on over here, and see the output. The result of the Brooklyn station is the intersection operation which is done between point and a polygon. Point, what was point? It was the stations. What was the polygon? It was the block. So when we are performing an intersection between a point and a polygon, what is the spatial type of output? It is point. Okay, and see the attribute table. I'm opening the attribute table. See, with each of the NYC subway station, the block ID, total population, whatever was the information attribute in the census block, it was automatically get associated with the subway station. Okay, are you getting this thing? कि अगर पॉइंट और पॉलीगन में ओवरले होगा, जैसे यहाँ पे हमने इंटरसेक्शन किया, पॉइंट और पॉलीगन के इंटरसेक्शन पे हमको आउटपुट में क्या मिला? हमें आउटपुट में पॉइंट ही मिला, लोअर लेवल ही मिलता है, मतलब लाइन और पॉलीगन का कराएंगे तो लाइन मिलेगी, पॉइंट पॉलीगन का कराएंगे तो पॉइंट मिलेगा। एट्रीब्यूट टेबल में आपने क्या देखा कि एट्रीब्यूट में ऑटोमेटिकली जो जिस भी ब्लॉक के अंदर वो फॉल हो रहा था, है ना, जिस भी ब्लॉक के अंदर ये पॉइंट्स फॉल हो रहे हैं उनका इंफॉर्मेशन यहाँ पर एसोसिएट हो गया। चलिए एक बार हम लोग यूनियन करके देखते हैं क्या रिजल्ट आता है। तो देखिए यहाँ पर, देखिए समझ में आ रहा है क्या हो रहा है, यहाँ पे यूनियन ऑपरेशन नहीं हो पाएगा क्योंकि पॉइंट और पॉलीगन के बीच में यूनियन नहीं होगा, केवल इंटरसेक्शन ऑपरेशन ही है जो यहाँ पर होना पॉसिबल है। तो समझ में आ गया? क्वेश्चन में अगर आपको ऐसा कहीं भी कोई जरूरत हो कि अगर आपको पॉइंट के साथ में पॉलीगन का इंफॉर्मेशन जोड़ना है, जैसे कि अगर पूछा जाए कि ये कितने, मतलब एक एस्टिमेटेड हमने दिया कि हर एक सबवे स्टेशन कितनी पॉपुलेशन में है ना, तो उसका एक हम एक अप्रोक्सीमेशन दे सकते हैं कि भाई जिस भी सेंसस ब्लॉक के अंदर वो सबवे स्टेशन फॉल कर रहा है वहां की उतनी पॉपुलेशन को वो पर्टिकुलर सबवे स्टेशन कैटर कर रहा है। ठीक, इसी का एक वेरिएशन और अब देखते हैं। लाइन एंड पॉलीगन, ब्रुकलिन स्ट्रीट्स है हमारे पास में और ब्रुकलिन ब्लॉक्स भी हमारे पास में है। इंटरसेक्ट, देखिए ब्रुकलिन स्ट्रीट्स, ब्रुकलिन ब्लॉक्स। ओके, इंटरसेक्शन ऑपरेशन टाइम लगता है इसमें थोड़ा। आउटपुट क्या मिल रहा है? लाइन पॉलीगन का कराएंगे लोअर ऑर्डर लाइन मिलेगा। ठीक है, एट्रीब्यूट टेबल देखिए सेम, यहां तक तो यहां तक रोड का जो था वो इंफॉर्मेशन है और यहाँ पर देखिए जो वहां का सेंसस ब्लॉक था उसका इंफॉर्मेशन आ गया। तो एक इंफॉर्मेशन और नोट डाउन करिए, यहाँ पर कितने नंबर ऑफ फीचर्स हैं इंटरसेक्शन के बाद में, नोट डाउन करिए। यहाँ मेंशन इट इज 30,647. अगर हम ब्रुकलिन स्ट्रीट में जाएंगे, क्या नंबर ऑफ फीचर्स इतने ही मिलने चाहिए हमको?
यस मैम।
सेम नंबर ऑफ फीचर्स होने चाहिए। मतलब अगर हम ब्रुकलिन स्ट्रीट खोलेंगे तो वहां भी 30,647 रोड्स होनी चाहिए, करेक्ट? इसके अपोजिट कोई आंसर देगा? अनइक्वल नंबर होना चाहिए। सब कह रहे हैं इतने ही होने चाहिए। इंटरसेक्शन के बाद का जितना आउटपुट है, यहाँ अराउंड 30,000 रोड्स यहाँ पर दिख रही हैं। बिफोर जो ओरिजिनल डेटा है ब्रुकलिन स्ट्रीट का डेटा, उसमें भी इतनी ही रोड होनी चाहिए। बाकी स्टूडेंट सोचिए और बताइए।
मैम हमने स्ट्रीट से ब्लॉक का कराया था ना मैम।
हम्म। सो ये साइलेंस हम यस के तौर पे ले रहे हैं कि सब लोग कह रहे हैं कि इतना ही होना चाहिए। चलिए फिर देखते हैं। ब्रुकलिन स्ट्रीट्स कितना दिख रहा है? वहां 30,000 था, यहाँ कितना है? 3,005। ऐसा क्यों हुआ? ये मिसमैच क्यों है नंबर्स में?
फॉर एवरी फॉर एवरी इंटरसेक्ट्स, जितने भी स्ट्रीट्स हैं वो ब्लॉक के साथ उतने नंबर ऑफ स्ट्रीट्स बनाएंगे।
यस, करेक्ट। यहाँ पर स्क्रीन में देखिए, इस एग्जांपल को देखिए, अभी अभी जस्ट बताया था ये चीज। जब इंटरसेक्शन हो रहा है, जैसे यहाँ पर रोड ऑफ फॉरेस्ट का इंटरसेक्शन हो रहा था, अब रोड 1 एक सिंगल रोड ना रह करके दो पार्ट में डिवाइड हो गई, दो अलग अलग फीचर्स बने, रोड 1 एंड रोड 2। अगर ओरिजिनल मैप में रोड 2 को देखें, वो फॉरेस्ट से इंटरसेक्ट होकर के रोड 3 एंड रोड 4 फॉर्म कर रही है। इसी तरीके से इस डेटा में अभी देखिए क्या हो रहा है। यहाँ क्यों बहुत बड़ा अंतर है? इट्स 3,000 और आफ्टर इंटरसेक्शन 30,600 समथिंग आ रहा है। यहाँ पे देखिए क्या हो रहा है अंतर। यहाँ देखिए, जब हम इसको सेलेक्ट कर रहे हैं, ठीक है, हम एक रोड सेलेक्ट कर रहे हैं, अगर देखिए ये पूरी एक रोड है। इसका हम एट्रीब्यूट टेबल में ओपन करा कर देख लेते हैं। ये केवल एक रोड है, इसका आईडी देखिए, अपने कॉपी पे सब लोग नोट डाउन करके इसका नाम 845 पॉलिन लाइन ID 134 स्टुअर्ट स्ट्रीट टाइप रेसिडेंशियल। एक आ रहा है, यहाँ सिंगल रोड है। अब दूसरे डेटा पे चलते हैं। दूसरा डेटा कौन सा है? इंटरसेक्शन डेटा है। फिर इसको इंटरसेक्शन डेटा को सेलेक्ट करते हैं, देखिए 1342. Okay. सेलेक्ट बाय एट्रीब्यूट कर रहे हैं. FID of Brooklyn Street is equal to 1342. अप्लाई. देख रहे हैं क्या हो रहा है. ये अंतर समझना जरूरी है, इसलिए इसको क्लियरली समझिएगा. 1342 आईडी के अगेंस्ट में अगर हम देखें, यहाँ पर 4 स्ट्रीट्स दिखा रहा है. FID ऑफ ब्रुकलिन स्ट्रीट 1342. टोटल कितना आ रहा है यहाँ पर 4. वहीं अगर हम ब्रुकलिन स्ट्रीट में करें, यहाँ पर हम लोग 1342 कर रहे हैं. अप्लाई. यहाँ केवल एक रोड सेलेक्ट हो रही है. ब्रुकलिन स्ट्रीट में कितनी हो रही है? 4 रोड सेलेक्ट हो रही हैं. नहीं, कुछ गलत हो रहा है. एक मिनट. सॉरी. ये स्टुअर्ट स्ट्रीट एक नहीं 14 पार्ट्स में ये डिवाइड हो रही है. और जो ओरिजिनल ब्रुकलिन स्ट्रीट में अगर हम यही एट्रीब्यूट टेबल को खोलें, तो स्टुअर्ट स्ट्रीट जो थी वो एक रोड थी. अब कितनी बन रही है? 14 स्ट्रीट्स बन रही है उसके अगेंस्ट में. ऐसा क्यों हो रहा है? क्योंकि वो एक स्ट्रीट डिवाइड हो रही है हर एक ब्लॉक के डिवीजन, हर एक ब्लॉक की बाउंड्री से. ठीक है, हर एक ब्लॉक की बाउंड्री से ये डिवाइड हो रही है. इस कारण से ये अलग अलग पार्ट्स में आ रही है. देखिए, ये एक पार्ट, ये दूसरा पार्ट. ठीक है, इस कारण से नंबर ऑफ स्ट्रीट्स जो होगा वो हमेशा आफ्टर इंटरसेक्शन नंबर ऑफ लाइंस बढ़ जाएंगी. इसमें किसी को कंफ्यूजन है तो पूछ लीजिए अभी. कोई कंफ्यूजन नहीं. चले नेक्स्ट, पॉलीगन ऑन पॉलीगन. ओके, इसका एक एग्जांपल दिखाते हैं. सपोज, ठीक है, पॉलीगन ऑन पॉलीगन ओवरले में एक चीज ध्यान रखिएगा, जरूरी नहीं है कि हमेशा सारे पॉलीगन्स जो होंगे उनमें एट्रीब्यूट हमेशा कंबाइन होता है. अलग अलग ऑपरेशन है हमारे पास में. यूनियन, इंटरसेक्शन, इरेज, सिमेट्रिक डिफरेंस, अलग अलग बहुत से हैं. अलग अलग में एट्रीब्यूट टेबल अलग तरीके से चेंज होता है. इसीलिए कभी भी ओवरले करते टाइम, जब भी आप प्रैक्टिकली परफॉर्म करें ओवरले, हमेशा ध्यान रखिए उसको पहले से करके देखना पड़ता है. हमें सीखना पड़ता है कि किस ओवरले में एट्रीब्यूट में क्या अंतर पड़ता है. एक क्वेश्चन है, बताइए. सपोज हमें NYC ब्लॉक या ब्रुकलिन ब्लॉक में से वो सभी एरिया हटाना है जो कि सबवे स्टेशन के 500 मीटर के रेंज में पड़ता है. कैसे करेंगे? We want to remove all those region from Brooklyn blocks which falls within 500 meter range of the subway station.
मैम पहले एक लेयर बनाएंगे जिसमें हम 500 मीटर्स रेडियस का बफर करेंगे स्टेशन के अराउंड, और फिर उसको मैम डिफरेंस वाले ऑपरेशन से इस लेयर से माइनस करा देंगे हम मेन लेयर से.
बिल्कुल. सो यहाँ पर अगेन सॉफ्टवेयर में टर्मिनोलॉजी बदलेगी. यहाँ पर हमारे पास में इरेज होता है. आपको अपना जो भी सॉफ्टवेयर आप यूज कर रहे हैं वो ऐसा ही करेंगे. जैसे आप देख सकते हो स्क्रीन पर, हमारे पास में दोनों लेयर है. एक ब्रुकलिन स्टेशन की 500 बफर के साथ में सर्कल्स हैं पर्पल कलर में, एंड ब्रुकलिन ब्लॉक्स येलो कलर में है. यहाँ पर हम इरेज ऑपरेशन परफॉर्म कर देंगे. इनपुट ब्रुकलिन ब्लॉक्स, sorry. Input Brooklyn block, erase feature, Brooklyn subway station buffer. Okay. Erase operation time लेगा अभी थोड़ा. This is the final output. ठीक है. यहाँ पर क्या हुआ? यहाँ पर हर एक NYC सॉरी ब्रुकलिन सेंसस ब्लॉक में से जो 500 मीटर अराउंड दी सबवे स्टेशन का रीजन था उनके बफर को यहाँ पर इरेज कर दिया गया. इसके एट्रीब्यूट टेबल में यहाँ पर कोई भी अंतर नहीं आएगा. ठीक है. इस तरीके से ये इरेज ऑपरेशन हो गया. इसी तरीके से कोई भी ऑपरेशन हो सकता है लाइक सपोज क्वेश्चन में आया कि नहीं ये तो सपोज अगर क्वेश्चन है कि आपको वो सभी रोड आइडेंटिफाई करनी है जो कि स्टेशन के विद इन 500 मीटर रेंज में फॉल करती है, तो क्या करेंगे? सेम ऑपरेशन चलेगा. बफर बनाएंगे 500 मीटर का एंड देन इंटरसेक्शन ऑपरेशन परफॉर्म करेंगे बिटवीन द बफर एंड द लाइन फीचर. इस तरीके से ये वेक्टर ओवरले बफर चलेगा, सॉरी ओवरले एनालिसिस चलेगी. ओके. नेक्स्ट ओवरले हमारा डन हो गया. नेक्स्ट हम लोग आ रहे हैं पॉइंट इन पॉलीगन एनालिसिस. पॉइंट इन पॉलीगन एनालिसिस मतलब नंबर ऑफ पॉइंट्स फॉलिंग इनसाइड अ पॉलीगन. ठीक है. दिस इज कॉल्ड पॉइंट इन पॉलीगन एनालिसिस. बहुत ही यूजफुल एनालिसिस है. ये ओवरले एनालिसिस नहीं है, ध्यान रखिए. ये दूसरी एनालिसिस पर हम लोग आ गए हैं. पॉइंट इन पॉलीगन ओवरले नहीं हो रहा है. पॉइंट इन पॉलीगन एनालिसिस, इस एनालिसिस के थ्रू किसी भी पॉलीगन फीचर के अंदर कितने पॉइंट्स फॉल कर रहे हैं ये निकालने के लिए किया जाता है. सपोज हमें जानना है कि एक सेंसस ब्लॉक में कितने सबवे स्टेशन फॉल हो रहे हैं, ये पॉइंट इन पॉलीगन है. सपोज एक डिस्ट्रिक्ट में कितने डिस्ट्रिक्ट हॉस्पिटल्स हैं या कितने गवर्नमेंट हॉस्पिटल्स हैं, ये सारी चीजें पॉइंट इन पॉलीगन एनालिसिस से आती हैं. और पॉइंट इन पॉलीगन एनालिसिस में एक नया एट्रीब्यूट केवल ऐड होता है. शेप में कोई अंतर नहीं आएगा, बस एक एडिशनल एट्रीब्यूट फील्ड ऐड हो जाएगी जिसमें उसका काउंट लिख करके आ जाएगा. तो ये पॉइंट इन पॉलीगन एनालिसिस होता है. इसको रीड आउट करते रहे हैं. द पॉइंट इन पॉलीगन ऑपरेशन इज यूज्ड टू डिटरमाइन वेदर अ पॉइंट lies inside or outside a polygon. If the polygon overlap, it is possible that a given point lies in one, many, or no polygon depending on its location. The operation is popular in GIS analysis because it is the basis for answering many simple queries like the point represents instances of a disease in a population and the polygon represents reporting zones such as counties. The task is to determine how many instances of the disease occurred in each zone. Like if we talk in current scenario, like dengue is quite rampant in several regions of Uttar Pradesh and even in several other states of India. So if the question is that, we want to create a map and we want to create it on the basis of number of dengue cases. So it can be created on a district wise, it can be created on a state wise. How this thing could be done? If we have the information, if we have the location of dengue patient, then by using this point in polygon analysis, we can create such type of things. Next, point represent the location of transmission line posts owned by a utility company, and polygons are parcel of land. The task is to identify the owner of the land on which each pole lies to verify that the company has the necessary easement and pays the necessary fees. Another example, point represent the residential location of voters and polygon represent voting district. The task is to ensure that each voter receives the correct voting form in the mail. So these all are the application of point and polygon analysis. Point and polygon analysis, for this there are several algorithms. One such algorithm is given over here, which is known as the half line or Jordan polygon. In this one, the concept is very simple, but it may not be effective in some of the cases. What this says, this half line method says that if you extend a line from a given point and if it intersects the polygon for the one time, it means that is it is located inside that polygon. And if you extend a line from a point and it will not cross any of the polygon, then it will lie outside the polygon. So there are different cases which are given over here. Like there can be some complex case, like there can be 3 intersection, there can be 2 crossings. So many times it is difficult to tell whether a point lies inside a polygon or not. But yes, over the time more sophisticated algorithms have come that helps us to identify whether a point lies inside a polygon or not. Okay. Now we are moving to the next, which is interpolation. Now this interpolation is a very useful technique. I will discuss about the interpolation, but before going into the interpolation detail, I think so everyone have learnt about the interpolation in mathematics. What is interpolation?
Computing the unknown points from a known point.
Anyone else?
Ma'am, we take the two points and we take difference of 2 point on the ratio in which it is change. The value of these 2 points are changing, and on the basis of the change occurring, we compute the value of the unknown point.
Okay. So in interpolation case, this is what it is going to happen. That in this one, usually if we have estimate, if we have a value of some point or if we have observed some of the point, then with the help of that one, we could estimate the value of other nearby location. So this is what the interpolation is. In case of GIS, this is very useful. Why? Because we need to create a continuous data set. Okay. In GIS, we need to create a continuous data. The raster data is a continuous data. If I open one such data, yes, here you can see that there is an elevation data which is present over here, and the elevation value is given at every location. Okay. The elevation is present at every location corresponding to every pixel. So is it possible to take the sample of every location? Is it possible to get the elevation value at every location? The answer is no. We cannot gather the location. Like suppose the resolution of this data set is suppose 120 meter. So it is not possible to gather the elevation value after every 120 meters. Suppose, and the area is in several kilometers. So that's why whenever we have to create such type of a continuous data, this type of continuous data, we have to perform the interpolation operation. Okay, so that's why the spatial interpolation is used, and it is very useful topic in GIS. Whatever data we are capturing, like suppose there is rainfall information at every location. Or, if I open this one, just wait. And this one is the weather information. Yes, this one. Now here you can see the AQI map. Okay. Nowadays there is a lot of this air pollution issues, and we are constantly listening that there is a lot of air pollution at this place, that place. Okay. Now here you can see the whole AQI air quality index map at this location. Okay. And the AQI index on the right hand side, you can see that there is a color ramp 0 to 500. The AQI is given over here. And on this map, you can find the AQI, okay, AQI of all the places, of all the district. This one is a continuous data. Wherever you move, you can get the AQI information like this. Okay. Like in Delhi, it is showing 500 AQI. Sonipat 473, Meerut 495. But if I move to the, like in Kanpur, it is 153. In Jalona, it is 219. In Allahabad, it is somewhere like that. So basically what I'm trying to say that this one is a continuous data that you are visualizing on the screen, but it is not possible to get that data. It will be measured at only few of the stations. Like at MNNIT there is one station, at Bamroli there will be another. So at within the Allahabad there are 4 to 5 places where this AQI is measured. But we are getting a continuous data for the whole location. How this is obtained? This is obtained with the help of interpolation. Okay. So what is interpolation? It is the process of creating a surface based on the values at isolated sample points. It is the procedure of estimating the values of properties at unsampled sites within an area covered by existing observations. Okay. So basically, what we are going to do, we are going to estimate the values. We are going to make a guesswork at those locations where the samples are not collected. The sampling is not possible at every location because of time and money limitation. Therefore, such type of interpolation techniques are applied. Now, there is one important concept which is spatial autocorrelation concept. If we have some data like, if I toss a coin, can we apply an interpolation over there? Tossing a coin, drawing a balls from a bag. We cannot make an interpolation on that one because they are the independent events. In GIS or in spatial data, when we say the data sets are not independent, they are not random. There is a property which is held by all the spatial data called autocorrelation property. What is this autocorrelation property? So there is a Tobler's law of geography. All of you visit the internet and search about this. No? There are the Tobler's law of geography. The first law, Tobler's law of geography states, as it is given over here, everything is related to everything else, but near things are more related than the distant things. If I take the example for this one, like suppose, if I measure the elevation, okay, so whatever elevation like what like I am at MNNIT, so whatever elevation is at MNNIT, you will find the similar elevation within 1 kilometer, 2 kilometer, 3 kilometer area, similar to that one. Okay, there will not be any abrupt change in the elevation. The value will be nearby to that one. But as I move away from the Allahabad, from my current location, like suppose if I reach Mirzapur, so the values will not be same. There are hilly region over there, so the value of elevation will increase. But if you measure the elevation nearby Mirzapur, again the value will come similar to that one. This is what the autocorrelation property says, or this property is based on the Tobler's first law of geography, that nearby things will be similar, and as you move away from that one, their value will get changed. That's why we always say, whenever we talk about the sampling, we always say, always take distributed samples. Always take the sample in a distributed manner. Why? Because if you start collecting all the data at one place, there will be a very little change. Like suppose if you are going to measure some pH value of a water or soil, something, okay? If you go to the nearby region, the soil or the water will show more or less similar property. But as you move away from that position, it will slowly and slowly start going to change. This is the basis of interpolation over here. Since the things are related to each other within the proximity, the value will be similar. That's why we can perform the interpolation. We cannot perform this operation if the values are independent, they are random, they are not related at all. Because in that case, you cannot predict the another value. Okay, so this is, remember this thing, write down this term, spatial autocorrelation. First, write Tobler's first law of geography, which is given on the screen. Write down this law. This is very important law because whatever prediction, whatever estimation we are doing, it is based upon this law of Tobler's. Everything is related to everything else, but near things are more related than distant things. Okay. And then write down another term, spatial autocorrelation. Write down this term, spatial autocorrelation. So spatial autocorrelation is the term used to describe the presence of systematic spatial variation in a variable. Okay, so this is how the interpolation is carried out. So for there will be one of the property, like there can be rainfall, there can be temperature, there can be elevation, any value, and with the help of interpolation we can make an estimation, we can make a guesswork of that value. Why we can do this thing? Because of the autocorrelation property that exists in the spatial data, because of the Tobler's first law of geography, we can perform this thing. Whenever interpolation is done, there is a two-step process. First one is the control point collection, and second one is the interpolation process. Okay, so first step is we need to sample the data. The sampling is the very first step, and the output of the whole interpolation process depends upon the sampling. Why? Because if you do not capture the variation in the data set properly, the output will not be correct, or it will not be that much accurate. That's why we need to gather the data, we need to sample the data properly. So when you were doing the georeferencing also, you have captured the control point, and at there also there was an interpolation. And here also you will learn about the sampling techniques, and then after we will learn in detail about the interpolation methods. So that's it from my side for today, because there is a quiz also from within a minute it will start. So there will be a quiz, and thereafter in the next term we will learn about the interpolation techniques. Okay. So thank you everyone. The class is over for now.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
Thank you, ma'am. Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Welcome to all.